In this tutorial, I am going to show you how to curve fit data. All right, as we mentioned in a previous video, LoggerPro is a nice program for entering in data and adding recording your points and having the computer generate the graph for you. Now, in this particular case, I ran a couple of different trials in which we were tracking the motion of an object, and that object moved over a 5-second interval as indicated here. And in each trial, it moved differently. So we had, in trial 1, we had a particular position. I also filled in some values for trial 2, trial 3, trial 4, and a trial 5. And we ran these different tests and got different numbers each time. Now, if we take a look in LoggerPro, what we mentioned before is that these axes indicate what values are marked over in our data table. So, for example, this would be plotting the position in trial 1 as this function of time. Now, if I wanted to look at trial 2, I could just simply click on here and look at trial 2 instead, or trial 3, or trial 4, and so on and so on. Or I could even look at all of them at the same time, which is a pretty big mess, but we can see that they clearly are not moving in the same way because they're all in different locations at different times. So I'm going to go back to trial 1 and show you a little bit about how curve fitting works. In this class, there's a couple of standard types of curves that we'll like to use. Please make sure you look at your reference sheet to see which types are valid to be used. So the first thing I'm going to do is I'm going to auto scale like we've always done before so I can see this a little bit better. Now again, notice that I did not put on the connecting lines. I'm just using point protectors, and I would like to curve fit this. So what I will do, and this is huge when you're working with LoggerPro, is this analyze feature. There's a lot of different things that we could use. Today we're just going to be looking at the curve fit. Now you might say, well, this looks like a line to me. Can I just choose linear fit? And the answer technically is yes. But we're going to stay away from that for the moment. Just double check to make sure there are no better choices, because sometimes it actually looks like one type, but it turns out being better fit as another model. So if we hit this curve fit button, we'll see that this dialog box pops up and it asks what type of graph do you think this might be. For example, is this a proportional graph? This is one of the choices that we can choose. Proportional means that as you double the x, the y value doubles. If we hit the try fit, we will see that it runs a line through the points here, and if I hit OK, we see that this curve fits this data perfectly. This would be considered a a proportional fit, which is also linear, except for there is a slight distinction between linear and proportional, and that proportional graphs start at the coordinate 0, 0, whereas linear could start anywhere on the y-axis, whether it be in the positives or the negatives, so it doesn't necessarily cross through this origin here. Now, there's a few things that I would also like to show you while we're at it. For example, the display of this video, or the display of the graph. Right now, what this graph is showing is a couple of different things, but what it is showing is it's showing trial 1's position. That's what this T1 is. As time goes on, that's what this little t is here. This a value is the value that's indicating how these two variables are connected. So the position in trial 1 as a function of the time goes by would actually have been, the position would have been 2 times whatever the time is. And if we look here, that kind of makes sense. If we took the time of 1 and times it by 2, we would get 2. If we took the time of 2, times it by 2, we would get 4. So it's giving us the mathematical relationship too. So if I double click on here, and I want to look at this a little bit differently. In this class, I tend to not like a lot of these numbers, so we're going to just drop the decimal places down to 2. Showing the standard error is something we're going to not use often in the class. That just is what some of this plus minus stuff was. It's just telling us how far off we might be. We put perfect data in here, so we had a plus minus of 0, meaning that it really isn't off at all. But I'll turn that off. And then the appearance will let us change the font. So I'm going to change the font up to a size 16 is what I like in this class, because when you put it into a Google Doc or something, generally these fonts are too small to see. So I hit OK. Okay, I'm just going to hit OK again, and we just simply see that we now have a bigger version of the graph, and it's telling me that this is my equation. This would be, again, known as proportional fit. Now, if I did the same thing for trial 2, and I auto-scaled it, which it appears that it already is, and I went to analyze curve fit, I would see that this is not actually proportional anymore. In fact, if I hit the try fit, it does not run through the data very well. So this cannot be explained by this type of relationship. The graph tried, or the computer tried to make the best fitting line that would handle this data, but that doesn't seem to do it. Now in this class there's a couple of choices that we can choose from this menu. Proportional is one. Linear is another one that we can explain. So we'll test out linear, we'll hit try fit, and we'll see, again, it's a line just like proportional, but notice it didn't run through the 0, 0. It also doesn't work very well. It's not bad, but this point is really far off. This point's very far off. And these two are about the same amount off, but below the graph as opposed to these, which are above. So it's not linear. Now, we can try to go through all the types that are here. We can try quadratic, which works pretty well, except for it's not easy to explain, so please do not use that one. Same thing with cubic, quartic, quintic. We don't really want to use these. Again, our choices in this class, according to our reference sheet, will be proportional, linear. I'll scroll down. We could also choose... did I miss it? Oh, yes, I did. Inverse. And if we hit try fit, we see that clearly is not correct. The other choice that we can choose are squares and square roots. So we have proportional, linear, inverse, square, or square root. But if I scroll through this menu, I will not find square or square root on there. And the reason for that is because they're not defined by this program. In fact, they're powers. Now, we could click on this power, but if we hit power, what it will do is it's going to give a value or a coefficient that would make the numbers work plus a specific exponent that would work. Now, I don't know about you, but I have trouble with exponents such as 1.97 power. I don't know exactly what that means. So we would rather work with powers that make sense. Now, this happened to be the second power, which hopefully you recognize as a squared. But we do not want to use power. We want to use variable power. If I click on variable power and we look here, the first power that I can use is power 2, meaning I'm going to go with a squared power. And if I hit try fit, I see that this clearly works. This is the type of graph that I have. This graph is represented, as a square graph, meaning that as the time doubles, the distance will quadruple. Okay, and we see that this is the equation for the graph. So it provides me with an equation. I would replace this a value with 1, and it would say that t2 would be equal to 1 times the time squared. All right, so this is just an introduction to curve fitting. All right, I'm going to go through a couple others really, really fast because this is starting to get pretty long. So if I went to trial 3 and we ran a curve fit, we would see that this looks to be a line. So if we hit if we hit curve fit here, analyze curve fit, and I tried the proportional again, we would see that this wouldn't work well because it's trying to force the line through 0, 0. So I go to my next choice, I look at linear, I hit try fit, and there it is. I see it's the right graph. For time purposes, I'm not going to change up the display, but I see that it gives me an equation with values to replace, so I can replace the m and the b with these numeric values, and this would give me the equation of this line and tell me the relationship. Again, if a pattern fits, then you have a relationship. If you have no discernible pattern and none of these types will work, then the graph indicates that the two variables are not related. All right, so we have 2 more trials to test. Okay, trial 4, if I auto scale it again, we said we have this descending power. Descending powers are generally indicated as inverses. So if I went to analyze, curve fit, let go of the mouse too early, sorry, analyze, curve fit, and I went through the list. Again, I see that linear does not work. I see that proportional certainly wouldn't work because this can't go through 0, 0. That doesn't really make much sense. So I look for my inverse, which is this one. I hit try fit, and there it goes. It does work well. This is an inverse relationship because the data fits this curve pretty well, and this is the actual equation for it. Finally, we look at trial 5. Trial 5 is our final of our graph types. If we auto scale it, we see that this pattern starts to go up, but then it starts to decline. This is a graph in which we have a square root relationship. So if I were to go to analyze curve fit and look for that pattern on here. Now, you might be tempted to say it looks linear. We run it through here. That's not too bad. But again, we want to run through all of our choices. So if I go down the square root, I will not find it. Again, we said it's a variable power. I click on here, and we said a variable power is either going to be squared, which is to the second power, which if we hit try fit, it's clearly not, or the square root is basically the same as saying something to the half power. So if we type in 0.5 and hit try fit, we see that this data fits perfectly and that in fact this is a square rooted relationship. Hopefully this video showed you a little bit about the standard types of curves that we will have. Again, proportional, linear, squared, square rooted, and inverse relationships, and how you can identify them using LoggerPro.